Hi, my dear friends. We're going to start another subject today, which I call global warming and what is causing it. To begin with, I have to tell you, I went through the same problem like all our scientists around the globe, and they still puzzled up, what exactly caused this global warming. But one thing, they know for sure, everybody agreed, that the too much carbon dioxide, is changing our weather pattern. But what I was able to understand, it was kind of shocking to me that the carbon dioxide actually, the global warming, it's actually were completely different than what most of scientists could have imagined, And let's get deeper into it. First of all, to begin with, I have to explain how our atmosphere is functioning, and then go on and say why is the carbon dioxide. Our atmosphere is molecules. They have a free will. They move any direction in close proximity, whatever. All their the motion of their electrons will take them, because the electrons constantly, they're rotating constantly. And that motion will they travel. If they absorb too much heat, they expand, and then move faster, and it goes like up and down constantly. When they cool down, the electron gets closer to the nucleus, and like they slow down and they come down, and they circulate constantly, non-stop, And to begin with, I have to tell you that the molecules, they have no effect out of the gravitational force. The only thing affects the molecules within atmosphere, the heat. You see, that's why we have high and low pressures. How they create that? You see, what happens when the ground it heats up. You see, when the heat is radiated into the atmosphere, the higher the heat goes, the more molecules expand. When the molecules they expand so much that their movement is becoming impossible, and like they're pulling each other, and they get stuck together, and they're pulling each other, and that's like they're creating artificial extended gravitational force. Like, for example, when you take the barometric pressure, when you check it out, not under normal conditions, which one is low pressure, it's a 92.92 the gravitation at a barometric pressure. But time of high pressure, it increases. It goes about another point or a point and a half or more, And that actually, you see, the higher the heat, the higher will go barometric pressure, depending on how much the heat radiated into that particular area. Okay, this is the way how our atmosphere functions. Our atmosphere has no effect. Again, I repeat, no effect from gravitational force. The only reason, again, in a previous video clip, I explained the only reason we have atmosphere because where exactly, it's 59 miles, that's the location where our gravitational force is pulsating. That the pulsation is constantly hitting and holding all our atmosphere toward the ground. Otherwise, we wouldn't have any of it at all. And you can see a good example throughout the solar system. Mercury, Venus, it's losing it. Still has somebody. It's in the process losing it. Or take the Mars. Has very thin atmosphere. See, it goes by the density of the gravitational force. Higher the gravitational force, higher the density of the atmosphere. Okay. Now let's go into explain the photons. We know already from the law of the physics. Pressure, and the heat are proportional. It is true that higher the pressure, you see, higher the heat, higher the pressure. It just rises right next to evenly, And that's true also for the pressure and the expansion of the gravitational force. Exactly, I use the same method to calculate, how truly the gravity works. I use exactly the same method: heat and pressure and expansion. It worked perfectly. Okay, and I said, you see what happened. You see the molecules, when they absorb the heat, they move uncontrollably. They're like, with the high velocity, they just move any direction or whatever they get forced by the pressure to move. They create a velocity with the heat to begin with. I mean, we know already Mercury, how much heat has the Mercury, and it gradually decreases toward the Mars, and until I'm positive it will reach by the asteroid belt. Probably it reaches to zero already, and there's the photons already. They don't move any farther than in the asteroid belt, within our solar system. Okay, and what it tells you that you see, like when the molecules, they have the energy within them, they can move and stay alive as long as they have the energy. But the heat, the more whatever they absorb, they release all with their journey, throughout their journey within the space. More heat they release, slower they go. And imagine this now. Why is that? Imagine that 100 miles away within our atmosphere, above our atmosphere, the heat rises 220 degrees Celsius. But when we reach down toward the Earth, it comes down to in a certain region, depend the region, it strike the surface of the Earth, like from 15 Celsius all the way to 35 or 45 Celsius. Okay, and why so much different? Why happened, with that 220 degree? It's only, we have 59 mile of atmosphere. Some scientists, they claim that ozone layer, it does everything for us. No, I mean, come on, they have to understand, that the things doesn't work like that in the nature. You have, 220 degree Celsius over there is the high pressure. How possibly weigh, thin layer atmosphere, has no strength to hold down, and will hold all that pressure? That's impossible. All the pressure, imagine in your mind, like all that molecules, they're like the ping pongs, blue ping pongs, filled up instead of molecules. And imagine the carbon dioxide made of black ping pongs, and the sun photons, they're made of red colored ping pongs, Now the red ping pongs, when they penetrate into our atmosphere, they're striking, every single molecule. Why? Because, because they discharge energy. Already the energy is discharged from them to begin with. And they are mostly made of mass, not energy, how the way, some scientists, they claim today. Okay? And when they come down, they strike in every single molecule. And by striking in those molecules, they shed their heat constantly. And when they reach lower atmosphere, where we have mostly the oxygen are the largest molecule within atmosphere, and they actually absorb more. And this should be clue to scientists. Why is that in the past? We had many times the Earth, the surface got frozen. The sun never lose, the temperature. Sun, start from as a young star, with a bluish white color, heat, always decreasing, it's going down, okay, and never decrease the heat. But what exactly what's holding the sun's photons down? Our atmosphere. The less carbon dioxide, less, you see, the more molecule, they absorb the heat from the sun's photons, but by the time when the sun's photons reach the ground, it has no heat to it left to penetrate to the ground, to heat up the ground and radiate the heat back into the atmosphere. Okay, and the whole it works. Just I said, it just if you think of it, you see why is that heat is increasing now? Because more the carbon dioxide we have, everything boils down the mass, the molecules they hold. Because the carbon dioxide has ability to heats up quick and cools down quick. The other molecules within our atmosphere, they heats up slowly and they cool down slowly. Imagine that. Why is that? In the summer times, and the areas where we have less carbon dioxide accumulation, you see what it happened. It stays warm throughout the night, and just early in the morning, just before sunrise, and then when I stood at sunrise, you see suddenly it cools down when the sun is rising. Why? Because when the molecules, when they're coming down, they're striking all those little molecules, and everything, when they completely cool already, that cool it brings down, toward the surface, toward us. And how they cool down to begin with. Imagine in your mind, each molecule represents like a cooling fan. They're like all those electrons, when they're revolving non-stop, they're creating, because the nucleus doesn't create heat. And all that, the rotation creates a lot of cold to begin with. Now this should be clue to you why, outer space, is so cold. Because, you see sun, so there's no surface for the sun heat and radiate the heat and heat it up the outer space. How it works. That's why you can see on top of the mountain always has a snow. Why? Because it's not enough surface to heat it up to radiate the heat into the atmosphere. If you even radiate the heat from there, it will come down to the lower field. Not in the upper atmosphere. It won't stay over there to begin with. See, that's why you see until the ground doesn't warmed up, or it won't radiate the heat back into the atmosphere. Nowadays, you see, the higher the speed of the photons, you see, the deeper they penetrate into the ground, and faster it evaporates the water. That's why you see nowadays the ground is dry, and imagine this, the more we dump more carbon dioxide, the worse it's going to get, and each, imagine the photon when it's coming out, it's going to be like a little chunk of fire, striking to the ground, and even, if drought goes on, you don't have to use any match to burn the whole lot of forest or grass area, it will catch a fire by itself, because the photons, the heat of the photons already will create the fire, and okay, this should be clue to you why, so bad it is the carbon dioxide for our atmosphere. Because again, I said it heats up quick and it slows down quick, because if you look at it, molecule is molecule, why is that the carbon dioxide? Again, everything boils down to the mass of the molecules, what kind of mass they have. The carbon, I said, you can test it and find out yourself. It heats up quick, it cools down quick, That's the process what it messing up our weather system too, because when it's hot, it's not allowing, the molecules, you see oxygen and oxygen to collect you see water droplets, and to join back with the hydrogen, create water droplets, because it's too much heat, and they expand it. They cannot pull their energy closer to start to collect the water, you see, or the hydrogen, or pull each other, create water droplets. And that's the problem. And what happened? This evaporated water goes even higher level. And what happened? The more it goes until there's a cooler area. And what happened? And suddenly when it comes down like a torrential rains, because there's so much evaporation is increased too within our surface of our oceans. Because imagine there is a certain degree, it increases already, evaporation of the water. The higher the heat and higher the evaporation. Why do you think, the Greenland, is melting out of control? That it should tell you, how high it is carbon dioxide, within a northern atmosphere. That the higher the concentration, higher the faster the speed of the photons, toward the ground, and how higher the striking, the more higher, deeper they penetrate into the ice or ground itself. Obviously, I said they're coming down like just fire particles themselves, because they're overheated particles, and they move out of control, and they have no control of any kind. Okay, and this I hope this will give you some clue and idea what exactly is happening. I said, how do I know even the discharge particles? You can do little simple experiment yourself. Take the magnet, take any magnet, and heat it up, and you will see it will get completely discharged. And imagine that's the came out of it, the same material. They got atoms within them. If that material is losing energy, I mean that should be a clue to you that the heat actually destroys the energy. It's that simple. That's the problem. Why there's no the condition of the Mercury and Venus, those two planets. Okay, and thank you. And this is this much for this video clip.